All right, let's do this. We're going to go on a little journey today, a journey that takes us from just kind of noticing something to being able to actually predict it. We are going to build a statistical model right from scratch and see how data analysts turn a giant pile of numbers into some real, genuine understanding. Okay, let's jump right in.
I mean, you've got to wonder, right? How is it that they seem to have this sixth sense for what's going to keep your thumb moving? Well, I'll tell you, it's not magic. It's math. And today, we're going to pull back that curtain and see exactly how it works.
So let's imagine for a second that we're data scientists working at a big social media company. The big boss comes to us and says, I need to know what keeps people on our site. That's it. That's the mission. We have tons of data, but where do we even start to crack this case?
Well, like any good detective, you don't try to solve the whole mystery at once. You start with one simple question. You look for a connection, a link between two things. In our case, let's start with the number of friends a user has and how many minutes they spend on the site every day. I mean, it makes sense, right? More friends, more stuff to see, more time on the site. But we can't just assume, we have to prove it with data.
So what's the first tool we pull out of our statistical detective kit? It's called correlation. You can think of it as our first, most basic clue. It's a quick and easy way to see if our two variables, friends and time, are even moving in the same direction.
So what is correlation, really? Well, imagine taking a super complex relationship and boiling it all down to just one single number. That's what correlation does. This number tells us how strongly two things are linked in a straight line pattern. Pretty neat, right?
And for our data, that number is 0.57. This is called the Pearson correlation coefficient. So what does that even mean? Well, since it's positive and it's over halfway to a perfect 1.0, it tells us, yeah, there's a moderately strong, positive linear relationship here. In plain English, as the number of friends goes up, the time spent on the site tends to go up too. So, case closed, right? Well, not so fast.
Okay, everyone listen up. This is probably the most important phrase in all of statistics. You absolutely have to burn this into your brain. Just because two things seem connected, it does not mean that one is causing the other, ever.
And if you need proof, just look at this. The correlation is 0.985. That is almost a perfect one-to-one relationship. But think about it. Does spending more money on Pac-Man and Donkey Kong cause more people to get PhDs in computer science? Of course not. That's ridiculous. This is what's called a spurious correlation. It's just a coincidence, and it's the perfect example of why we have to dig a lot deeper than just a simple correlation. So, to avoid that trap and move from just finding a clue to actually making a prediction, we need a better tool. We need to build a model. And for our first attempt, we're going to use something called simple linear regression. This will let us describe that relationship between friends and time with a lot more precision.
Okay, check this out. Our simple model spits out two really important numbers. The intercept, that 22.95, that's kind of our starting point. It suggests that a user with 0 friends would still spend about 23 minutes on the site. But here's the juicy part, that num_friends number. That plus 0.904 means that for every single friend a user adds, our model predicts they'll spend about 0.9 extra minutes on the site each day. See, now we're not just saying they're related, we're saying how they're related.
But here's the reality check. How good is this model really? This number, it's called R-squared, gives us the honest answer, and it's 33%. What that means is that the number of friends a user has only explains about 1/3 of the story. It's definitely a piece of the puzzle, but wow, there's a lot of the puzzle still missing.
And this is the exact question every data analyst has to ask themselves. Our simple model was a good start for sure, but 2/3 of why people are spending time on the site is still a complete mystery to us. To solve it, we are going to need more clues and a much more powerful tool.
So it's time to level up. To get a better, more complete answer, we're going to upgrade our toolkit to something called multiple linear regression. Now, it sounds fancy, but the idea is actually really simple. It just lets us throw more variables, more clues into our model all at the same time, hoping to paint a much clearer picture of what's really going on.
So, what new clues are we adding to the investigation? Well, we're keeping number of friends, of course, but we're also adding how many hours a user works each day and whether or not they have a university degree. The question is, will these new puzzle pieces help us solve the mystery?
And boom, now this is the payoff. Look at that jump. Our R-squared, the amount of the story we can explain, skyrockets from 33% all the way up to 68%. We literally just doubled our model's predictive power by adding 2 more variables.
Now we're explaining over 2/3 of what's going on. This is a massive leap forward.
Okay, so let's break this down. The num_friends variable is still super important. And look at hours worked. For every hour someone works, they spend almost 2 fewer minutes on the site. That makes total sense, right? But then, look at degree. See that p-value? 0.356. That is really high. In statistics, a high p-value is basically the data whispering to you, hey, this one's probably not important. It's just random noise.
So we built a much more powerful model, but it's carrying some dead weight. That degree variable isn't really helping. So the final and maybe most important step for any good data scientist is to refine the model. We want to trim off the useless parts to make our prediction machine as lean, efficient, and reliable as possible.
Now, we don't just guess what to remove. There's a smart, systematic process for this, and a common one is called backward elimination. It's pretty logical. You start with everything in the model, you find the weakest link, the variable with the highest p-value, which for us was degree, and if it's not significant, you kick it out. Then you rebuild the model and do it all again until every variable left is a strong, meaningful predictor.
But how do we know for sure if removing a variable actually made the model better? For that, we need a smarter metric than regular R-squared. We use something called adjusted R-squared. The great thing about this number is that it actually penalizes you for adding in useless variables that don't really help. It's our ultimate judge for comparing which model is truly the best.
And this table right here, this tells the entire story of our investigation. Just look at that last column, adjusted R-squared. Our full model and our refined model are tied at 67.5%. They have the exact same predictive power. But our refined model does it with only 2 variables instead of 3. It is just as powerful, but it's simpler. And in the world of statistics, simpler is almost always better. That refined model is our champion.
So, after that whole journey, from a simple hunch about correlation to building and then refining multiple models, we have our final answer. We can now say with a lot of confidence that we can explain almost 70% of user behavior with just 2 things: how many friends they have and how many hours they work. That is an incredibly powerful and actionable insight.
So we built this amazing model that explains almost 70% of why people do what they do on the site, and that is incredibly powerful. But it also begs the question, right? What about that other third? What story is being told by the parts of our behavior that the models can't explain? Now that is something to think about.